Good morning, everybody, and welcome to the second webinar on using advanced camera systems for environmental monitoring of transportation corridors. I'm Fraser Schilling with the Road Ecology Center, and I have a couple of able colleagues in the room who are going to help answer questions. You'll notice that there's a chat box that you can type questions into or comments. Any technical issues that you might have with audio or seeing the slides, etc., please let us know. If you have questions about the presentation, please ask them as we go along, and we'll try to answer them in the chat box as we go along. Other questions that are more general, we'll be answering towards the end. So welcome, everybody. You're all on mute because there's quite a few of you. And I'm sorry about that. It would be nice to have a conversation. If you're listening to this on your computer, it might be better to call in. If the audio is working out, then that's fine. We have found that the audio is a little better on the phone, which is why we recommended it. So I'm going to go through a series of slides, and in between a few of the slides, there's some polling questions. These are questions for you all to answer, and you'll be able to see what other people on the phone are up to in terms of camera traps, camera systems. So please, when those slides show up, they'll be white. Please feel free to click on those polling questions, and so we can see what everybody's doing in the field. I'd like to thank the National Center for Sustainable Transportation, especially Natalie Ruiz, who's in the room, and Laura Podolsky for helping run this webinar. You can check out their Twitter feed at NCST_research. I'd also like to acknowledge a lot of people, especially the Federal Highway Administration staff, Deirdre Remley, and other staff who have helped this project get off the ground and really be successful. It's funded under the Early Advanced Research Program with an agreement to the University of California at Davis. I'd like to especially thank here at UC Davis, David Waitchen, who developed the web system that we're going to talk about, Kevin Taniguchi, who is a technical assistant with us, and then Patricia Kramer, Dr. Patricia Kramer from Utah, who I will highlight where she helped in the middle of the presentation, but she was instrumental in getting a lot of our cameras into the field. Catherine Harold in the Bay Area in California was also very helpful. A variety of student interns, and then a lot of state partners from state DOTs and fish and wildlife organizations. So the first polling question is just to get an idea of how many of you use trail or wildlife cameras in your work right now. So please click on the answers yes or no on your screen. We'll let that go for about 30 seconds and then show everybody what we're up to. So it looks like most of you do use cameras in your work right now. For those who don't, and for those who do, we are going to go through a few basics, but we'll keep those pretty short. There's a lot more information on our website at wildlifeobserver.net. And I should have noted that at the bottom left, usually, of each slide, you'll see the web address, wildlifeobserver.net. So if you want to write that down at some point, if you weren't familiar with it, then it'll be there for quite a while. This is the flow of the webinar. I'm going to introduce the overall project. I'm going to introduce using cameras and some of the terminology so we're all on the same page. And then I'm going to talk about two kinds of communicating camera systems, cell communicating cameras and Wi-Fi communicating cameras. I'll then talk about the web system we use. I'll use the term web-informatics sometimes, or web database, and they are all referring to the same overall system. And then finally, I'll talk about some next steps for the project for those who are interested, especially if you're interested in joining in, participating somehow. So this is the project overview. The first part of our project, which I'm not going to talk very much about, was to develop a plan for automated image analysis. I'll touch a little bit on that later. But basically to investigate different ways that we can carry out automated image analysis and pair that with our automated tools on the website for managing images, wildlife images. We also investigated and tested different advanced camera systems, and the advanced part of it is basically, can you self-power it in the field, and does it have communicating ability? We developed a web system to intake, manage, and share data from cameras, and I'll explain what that means. All of that is at wildlifeobserver.net. And then finally, we did all this in the context of DOTs so that we can help meet their needs, since this is a Federal Highway Administration funded project. We also, through the DOTs, or in addition to the DOTs, worked with a few fish and wildlife organizations and NGOs. Basically anybody who came along who wanted to look at how wildlife interact with roadways and highways. Some of the objectives of our projects, which also are some of our conclusions, is that the system can be used to manage wildlife camera trap projects. We were able to automate several steps in the pathway of images coming from cameras to the analysis stage, so basically data that you could use in different kinds of analyses. We found that different kinds of groups could be supported through this web-informatics system. We were able to accelerate data management, analysis, and sharing, and so that was an important consideration, is reducing the amount of time it takes to manage what is often many thousands of images. And we found that transportation organizations and others can more easily conduct and share their camera trap projects using our system. It's not the only way to do it, but we found that we were able to speed up a lot of the steps. And that's part of the justification for the project, is that there has been a very slow movement in the field of camera traps to incorporate some of the technologies that are out there. Typically, a camera employs an SD card to store images. Those images are manually saved onto a desktop computer, and then the data, the descriptions of animals and their activity are stored in a spreadsheet of some kind. That's a very typical practice, and what's lacking there is that there are cameras available that can communicate directly with servers and computer systems. There are automated tools for extracting data associated with images, and there are web systems that we can employ to share data online, which then makes it easier to share with partners. We field tested our camera systems, and the black squares are places that we deployed cameras for quite a long time. The green circles are more recent or potential involvements, and so we tried to work with a variety of different states to make sure that what we were doing was not just a California project where we're located, or a Rockies project where Dr. Patricia Kramer put in a lot of the work. So we were complementing a lot of needs. Some of those were structures that were built for wildlife movement. Actually, all of the pictures here on this slide are of structures or animals, in one case a person, that were built for wildlife movement. And so that was a really common activity. But we also used cameras in systems where the structures weren't built for wildlife and they just incidentally used those structures. Our users were transportation organizations, land management and wildlife agencies, and then contractors and consultants, including universities that work with those organizations. So here's another type of polling question, and basically wondering what type of organization or affiliation you belong to, and I'll share that in a moment, and you can see what everybody else on the webinar, who they're affiliated with. So I'll just give you a few seconds to fill that out. And it looks like most of you are associated with transportation and government, with quite a few consultant, NGO, and academic partners as well. So thank you for completing that poll. So I'm going to talk about camera trap terminology and some uses that are made of camera traps. First of all, when I use the term camera trap, it's the same as trail camera or wildlife camera. I might use any one of those terms, and they basically refer to the same instrument type. These cameras are usually motion and heat triggered. They're remotely placed, so they're far away from people and support usually. They're usually battery and or solar powered, and they usually need periodic maintenance, including recovering the SD card to get the pictures from it. There's a lot of different kinds of controls that are possible. There's some consistent controls related to motion sensitivity, sensitivity of the sensor, etc. So there's a lot of things you can control in taking the pictures. And most of the camera models that are out there do not communicate. And so there's only a few cell communicating models and a few Wi-Fi communicating models of camera out there. There's more cell communicating models than Wi-Fi. There's only a few true Wi-Fi. Some cell communicating cameras are called Wi-Fi or wireless, but they're really communicating through a cell network. And the way that works is that the camera sends basically messages, an image to an email address and or phone number. The Wi-Fi cameras use conventional Wi-Fi to send their images to a field computer of some kind, which then transmits it to a server. The camera traps are usually deployed in large groups, small to large groups, to cover a preserve area or some kind of natural area or a structure such as a highway or wildlife crossing structures across a highway. There are a lot of different ways that these have been used, and there's some standard guidance out there. For those who are not familiar with the two references I have here, Meek et al. 2014 and Radcliffe et al. 2014, please email me. You'll see my email address at the end of the webinar, and or you can go to wildlifeobserver.net and find it there, and I'll send you those papers. There's a lot of variation in camera models' abilities, and the placement of cameras can affect how the cameras sample the animal movement. And so the next couple of slides, I'm going to talk a little bit about that and how we've incorporated that into our web system. So besides the differences between manufacturers and models of cameras, which you would expect if you buy a camera from Bushnell or Reconyx, you'd expect them to be somewhat different from each other. We've also found that within a model, sometimes you have unit variation. And so that inter-unit variation actually changes your cone of detection, which is the area in front of a camera where an animal can be detected and a picture taken of it. And so that can vary between models of cameras, and it can also vary between units. And so knowing about that, that sampling area is really important to know what you're actually sampling. When we know the characteristics of the camera, and this could be how far away it can detect animal movement or take a discernible picture of an animal, how that varies by day or night, the angle of the cone, what the camera will actually take a picture of, then we can set up sampling regimes, and so we're really covering the area we want to sample, whether it's cameras sort of back-to-back, so they're covering a potential line of travel, or side-by-side covering an area, for example, the opening of a wildlife crossing structure. And there's a variety of ways that cameras have been set up or being set up. Out in Virginia, a colleague there has set up cameras alongside a highway. We're setting that up to understand how wildlife move in relation to the highway, not in relation to structures, but just approaching the highway or a fence line, moving along it, potentially crossing. People also look at wildlife movement away from the highway because wildlife have aversion to highways and roadways quite often. And then for those animals that do cross through structures, the simplest model is that we might have a camera at one end, that's the very simplest, or one at each end, which is the more typical simple model. And so that's shown as D on the slide, D1 and 2. And then Sometimes we have more elaborate cameras where we have multiple cameras associated with a structure and even some cameras away from the structure, and that tells us how animals approach. We can confirm whether or not they crossed and probably get a better sense of their behavior as they approach and use structures. So I'd like to ask a question of you all, what types of studies you're using camera traps for. So if you could please indicate on this polling slide the kinds of studies you're carrying out, then we can share it with everybody. I'll give you a few seconds to do that. And it looks like a pretty even mix, dominated by highway structure monitoring, but those looking at wildlife behavior and wildlife occupancy or occurrence are obviously also participating here. And that's I think, representative of the field of camera traps in general, where we see them used to understand how wildlife occur and move, and also how they do that in relation to infrastructure. So I'm going to talk about camera technologies right now. These are, again, a reminder, two kinds, cell and Wi-Fi communicating. And just as another reminder, any questions that you all have, feel free to type them into the chat box, and we will try to answer them as we go along. And also, at the end, we'll also answer questions. So there are a few models of cell communicating cameras out there. For those of you who have looked at this, you'll know that there's 4 or 5 major manufacturers of cell communicating cameras. We tried 5 manufacturer models, and we focused on 3 manufacturers in particular: HCO, which makes 3 different models that we tried; Bushnell Wireless, which makes 1; and Reconyx, which makes a couple of different models. We also tried a Wi-Fi communicating camera. We tried 2, and the one that we focused on was the Buckeye X80, which I'll talk about in a minute as well. And we tried a few non-communicating cameras and focused mostly on a model of Bushnell, used to be Trophy Cam, and this is actually a model of the Trophy Cam called the Aggressor. Not a great name for a camera, but there you go. These are all theoretically no-glow cameras, which means that the flash is IR and not theoretically not discernible by animals. For those of you who use cameras a lot, you'll see that sometimes animals are looking at the camera, and it's not obvious, and I'm sure somebody should test this, whether it's the flash that actually is detectable or the sound of the camera as it's activating. Somebody asked a question about why not test Moultrie. That's a great question, and there's a couple of other manufacturers that make good cameras, and we probably should have tested those, and it really came down to just picking out the ones that we had good experience with and some that we didn't know about, and we didn't get around to Moultrie. But this is not an endorsement of products, by the way. This is just talking about the ones that we did use. So the cell communicating cameras, we came down to 2. The Bushnell Wireless we found was the best overall, and the reason for that is that the initial cost was very low. You'll find if you go online that you can sometimes get them for under $300. So this is a cell communicating camera for less than $300. The ongoing data price is about $10 a month, and it's high reliability. One important consideration is that there's no downtime for transmitting the picture. Most cameras, cell communicating cameras out there, once they've taken a picture, they will pause the ability to take the picture and transmit the image, which takes about a minute. So that means you have a minute downtime. The Bushnell will take back-to-back images and then transmit them when the camera is at rest. And we found that these cameras work great, just like other Bushnell cameras, in a variety of weather conditions. Somebody asked a question about cell data plans. And in this case, the data plan is through Bushnell. We have found that the basic $10 a month worked out fine in terms of volume of pictures that it could handle, but it is through the Bushnell server, and that does limit how you can manage the pictures that come from that server. Another model that we used, and most of our cell communicating cameras are this model, is the Spartan GoCam, which is made by HCO Outdoors. And the initial price for this camera is higher than the Bushnell. The reliability is great. Somebody asked about how well the cameras work at very low temperatures. We haven't seen any much below, I think, minus 15, minus 20. I'm not sure how well they work down below that because we haven't had them in the field below that, although I should check that and make sure that's true. You'll see the deer on the left is the temperature is minus 12 degrees Fahrenheit. That camera had no problem functioning. It continued to function all a year later. The picture on the right, although there were a couple of battery changes in between. The main effect seems to be on battery life. This camera is in Colorado, and it's got a solar panel attached to it, which definitely helps with battery life. The only issue with this camera is that it does have a downtime for transmitting. And so once it takes a picture, it's down for a minute while it transmits the picture, and then it's up again for taking more pictures. The Wi-Fi communicating cameras, there's a very few models available, and we used one in particular, Buckeye Cameras X80, and there's several characteristics of this camera that make it optimal. Somebody just asked a question about the Bushnell. Does it use 2G or 3G to transmit? I think it uses 3G. I think that that's a required protocol now for all the cell communicating cameras. The Spartan GoCam uses 3G, but only a couple of years ago they were using 2G. But I'm not positive about the Bushnell. So the Buckeye camera, Wi-Fi communicating camera, it allows daisy chaining, and I'll explain that in a moment. The data transfer costs are very low because the camera is communicating via Wi-Fi. The base station costs, and actually the camera costs, are fairly high, but we were able to bring the cost down by making our own field station, basically, and I'll explain how that works. So the model system for Wi-Fi cameras, this is sort of a typical setup, is that you would have a series of cameras, and in this case the Buckeye can communicate among 254 cameras can be daisy chained to one base station, and that means that a camera can communicate with the next closest camera and so on, sending the data through, so basically using an individual Wi-Fi camera as a repeater. So if you imagine that the camera to the far left is the furthest away from the base station. If it takes a picture, it will send it to the next camera and so on down the line until the pictures arrive at the base station, which is indicated by the antenna and the laptop. These can all be powered by a solar panel for each camera. The camera is on the left side of the image, and then the black box is the battery. So each of those camera images there's the camera and a fairly large battery. The company claims a mile to 2 miles line of sight transmission. We haven't tested that since most of the terrain that we use our cameras in is fairly rugged and a lot of topography. I would guess that you wouldn't be able to do a mile because you're not going to have line of sight quite often, but I imagine if it's doing a mile to 2 miles line of sight, you could probably do 100 or 200 meters. But this is definitely something that you would need to test in your particular terrain. So the images are transmitted to a base station. That base station has its own antenna, Wi-Fi antenna, to send it to either some kind of home station, and so if you were on a preserve, this could be the home office. If you were along a highway, this could be the DOT maintenance yard, but some way of transmitting that information from a field computer to we'll call it a home computer that has a landline link to a server. And so basically then you're using Wi-Fi to collect the images from all the cameras in the field, and then using Wi-Fi again to transmit to a home computer, which has a landline to a server. That's sort of a typical model. The way that we adapted this, and it was partly to reduce costs and partly to reduce the amount of space it took to accommodate the field computing, and this was from a security point of view. So we have a series of cameras. They communicate with the base station, but now this antenna, instead of being connected to a larger field computer, is connected to a very small Intel compute stick. And this thing is about 3 to 4 inches long, about 1.5 inches wide, and very thin. So this is a very small device, and it means that you can hide it, secure it much more easily. The power use is also much lower, which means your solar panel and battery requirements are low, and heat generation is very low. So all of those capacities make this a very nice, compact system. We connected the compute stick to a hotspot, which is also fairly small, about the size of a deck of cards, and that allows us to communicate through the cell network directly to the server. And so we sort of sidestepped the long-distance Wi-Fi problem, basically because it was very difficult to find conditions where that would work, and use the cell network to communicate directly with the server. So in the field, we have a series of Wi-Fi communicating cameras. They don't each require a data plan, and so you could conceivably link a lot of Wi-Fi communicating cameras through one hotspot, one data plan to the server, significantly reducing your data transmission costs. The cost of the system is up to a little over $3,000 for if you were to buy all of the parts separately from Buckeye Cameras, and then each additional camera is another $900. We shaved up to $1,000 off of this with the devices on the right-hand side, where we used much lower power compute stick, Intel compute stick and hotspot combination, and so that's on the right side. On the left side, you can see the basic camera and battery pack combined with a solar panel. And so the left side is what if you were to go to Buckeye Cameras on their website, this is what you would tend to buy along with a battery, which is not shown. And then on the right is our cost-saving implementation, basically because we felt like that was going to be a barrier if people had to spend a lot more on the field station. There's a question about range of temperatures. I'm not sure about that. The thing we did test in terms of temperatures was the heat generation for the field computer. And so we tested laptops in this environment, and we did get some heat generation. We were basically enclosing everything in a box that we could hide in the field or secure somehow. We found that the compute stick did not really generate any heat. So from a heat point of view or a cold point of view, basically the equipment, if a computer can function at -20, then this system will work at -20. But lead-acid batteries, which are the basis for a lot of this, I'm not sure about how well they deal with it. Batteries are usually the weak point for cold temperatures. And another question, does any of this work in highly remote areas with no cell coverage? No. What you would end up with is storage of all of the images on the compute stick and the inability to transmit it through the hotspot. And so you would have to recover all the information from the compute stick, which is similar to recovering it from an SD card. I suspect the advantage you'd have is the information is now secured away from the cameras so that if the cameras were stolen, you haven't lost the data. But if you're in an area with no communication, then the data is just going to stay out there until you go get it. Another question related to, have we seen issues with batteries leaking, rupturing, et cetera? No, these are sealed lead acid. I think you could probably find conditions where you would get damage, and we haven't had anything damaged by wildlife, as also somebody asked if a bear started to play with it. Basically, we would recommend that you bury a lot of this underground from a heat point of view especially, but also just protecting your equipment, securing it. So here's another polling question. Have you used or are you using these kinds of communicating cameras in your work currently? So if you could just spend a couple of seconds to answer that. And while you're doing that, somebody asked a question, can you get a satellite connection for any of these cameras for very remote sites? And there are sat phone types of communicating which is possible. And so yes, I would say if you can do this with a Wi-Fi antenna and cell hotspot, you can do it with a satellite connection. I think your costs would go up considerably, but for some places that are highly remote, that might not be an impediment if you're still collecting data and able to communicate it back. So here's how most of you responded. A few people are using cell communicating cameras. No one is using Wi-Fi. Some people are using other, and that would be interesting. For those of you who indicated other communication, if you could just type into the chat box what you're working on, then we'd be interested in finding that out. But most people seem to not be using communicating cameras. So hopefully you're finding this information useful. I'm going to talk about the web system next. And as a reminder, the web address on most slides is in the bottom left-hand side, and it's wildlifeobserver.net. Some things about the web system, and these are comments that came after our last webinar, so these are some of the things that people asked about. The system is free to use. It's suitable for managing any camera trap project. We try to include a lot of different attributes in the system so that it's suitable for a wide variety of projects, but we can't anticipate everything. So if you start to use it and you find that there's something missing that would suit your use, please let us know. There's no current limit on data uploads. You could upload hundreds of thousands of images. It will take you a while, like it would to upload data to any system. So please keep that in mind. There's no current end date in mind. So if people upload data into the system, you're not going to suddenly lose it. And we are keeping in mind that this is really a legacy data set, so it's not going to be lost. We at the university, we manage all data with the long term in mind. The person uploading the images who took the original image is the owner of the data. We don't own data that you put on our system. We are just helping you to manage it and share it with the world. And then finally, we back up the data periodically, and somebody asked about this. And that period is?
Well, we back it up every night.
Oh, every night. So every night the data is backed up. That was David Wagen. Thank you, David. So some of the system components, this is looking a little beyond the web part of it. And I'll just answer a couple more questions that came in. Are the data publicly accessible? That depends on the person managing a project. So you can decide to share or not share your project and the data with the world. You can also select at the species level. You're allowed to select at different levels as to whether or not you want to share information. So just let us know about that. In general, you can decide to share your project or not share your project, and people have decided to do both of those things. So you would click on, to do that, when you're setting your project up, you would click on a place that indicates whether or not you wanted it to be private or public. So some of the system components, there's the instruments that are either non-communicating or communicating. There's the web system itself, which is built using Drupal as the content management system for those of you who are interested. It allows you to manage the project, upload data, code the data, manage the data, visualize the data, share the data with the world or not, or share it with partners. The people involved are partner organizations and individuals that you decide as the project manager. We've developed some help documents and how-to videos. You can go to wildlifeobserver.net/help, and that will give you some good startup information as well as this webinar. Somebody asked a question about adding a logo to images. We don't have a method currently to automatically add a logo to images or a copyright stamp or anything like that. So we recommend that if you want to do that on your desktop, and there are tools that allow you to do that fairly easily, and then upload your images. The way that this system works, so this is sort of the model diagram, looking at the block on the left. And I'll use my little pointer. We'll start at the top. Wildlife Camera Project. We think of the way that people typically do these things are as projects, and these are projects that take place out in the world. And so the project takes place at multiple locations, one or more locations, and this might be a highway crossing structure, a patch of forest, a wetland, etc. And at each location, you might have one or more camera positions. And this is the actual spot on the ground where a camera is positioned. And so for a highway animal crossing structure, you might have multiple cameras. For a patch of forest, you might have multiple cameras. And so each of those is a camera position. There are also going to be one or more participants in your project. And so these are all associated with the project. They have to have accounts, which I'll talk about as well, and then they can be associated with the project. And then there's other kinds of information you might want to have as part of your project. You can link resources, reports, maps, etc. to your project. And I'll talk about how to set up a project in a moment. So the blue box and red box, the blue box indicates that if you have multiple camera positions, this can help you to confirm things like crossing events for a mitigation structure. And if you have multiple images from a single camera, you can use those to confirm an animal activity associated with a structure or to confirm the identity of an animal. Those are examples of how you can use these multiple cameras and multiple images. Our database that's behind the sort of the web views that you'll see is a relational database, and this is the data model for that. And so, so that you don't have to worry about writing all of this down hurriedly, as a reminder, the presentation will be online after the webinar. There's already a presentation up there from the last webinar, but we'll put this one up there. This is slightly modified, so we'll put this one up there as well. And so this, basically the database records multiple attributes associated with an image, its geography, date and time, and other things that you might indicate, such as animal activity. All of that is part of the database, and so that means that you can query the database to find out certain kinds of information about structures, species, anything related to geography, time, animal, users, etc. This is the flow of information, and so I'm going to start at the left and move over to the right and start at the top left. And this is a sort of a typical operation. The images are on an SD card. The SD card is manually retrieved from a camera, and now you have an SD card with images on it. And those usually contain a lot of pictures of animals and sometimes contain a lot of images of something else, like blowing grass, or if you have sudden light changes, etc., you might have a lot of those. So those images are taken out, and we upload the images of animals. And there's two ways that we have to do this from this manual approach. One is a one-by-one approach using a web form. So each image is uploaded one by one, and the attributes for the image are recorded. Another method is a bulk upload, and this is basically a zip file. You would take the wildlife-containing images from a single camera that you've recovered the SD card from. So the wildlife images are contained in a single folder or subdirectory, and you would zip that up and upload it to the website. The website then automatically, and this is the purple line here indicating an automated approach, they're automatically attributed with the date, time, and geography of the camera. And this information is extracted from the EXIF data from the image. And so every image has what's called EXIF data associated with it. And these are extracted, and a record is generated from that. Also, the camera exists in a certain position, and when you upload the data, you're uploading it associated with that position. So the geography, the position, and the project are associated with the wildlife image. So that's all automatic. And then the manual process is to tag the image, and I'll talk about how to do that, with the species, the animal activity, et cetera. And all of that ends up in this relational database, which can be queried. The other main approach is through communicating cameras, and these are either Wi-Fi or cell, and they communicate directly with the server, and so they send the images through this process of extracting the EXIF data and creating the record. So that's all automatic, and it's sent to the area on the website where you would tag the images for the identity of the species and any activity, and that would be entered into the database. So basically, the communicating cameras send the images all the way through into the web system, and the only task you have left is to identify the animal. Just give me a quick pause. Natalie, I'm sending you something. Can you respond to it? Thanks. Sorry about that. Okay, so this means that we can manually or automatically send images to our database, which allows us to then manage those images. Somebody asked a question about what is a position. A position can be a georeference position, and I'll show an example of that in a minute. Someone else asked about whether or not non-wildlife images can be filtered automatically. That's something I am going to address a little bit later, but the prequel to that, the preview to that is we are working on ways to filter out, automatically filter out those images that don't contain animals or something of interest. So now I have a polling question, and this is basically about how you're currently managing your data. What kind of database do you currently use to track data from camera traps? So I'll give you a few minutes to fill that out. And so as a reminder, just click on the little box indicating whether you use spreadsheet, relational database, or web-based system. If you don't use any of these, then don't worry about it. Okay, so about 2/3 of you answered, indicating that most of you use spreadsheet and some of you use relational database and some of you use web-based system. For those of you who use a web-based system, if you wouldn't mind just maybe sending us a chat telling us how you do that, because we'd be interested to see what other organizations do. Another question came in, are there opportunities to create security levels, specifically to use volunteers to catalog new photos without having access to the entire database? Yes, we can do that. So that means that people could come in and tag photos and not fundamentally modify the project. So I'm going to talk about steps in using the web system. This is your basically preview to how to use the web system. It's not intended to get you completely off the ground if you've never even looked at it before. We do have help resources on the website that should be able to do that, and you can also contact us. So the primary steps in using the web system are to create an account and log in like you would on any web system. You then create a project, which is essentially a reflection of your project that you are running in the field with camera traps. You identify the project members, and those might be people who have the same responsibility as you, or might be just there to identify the animals in pictures. And you give us a short description of the project. You then create monitoring locations, and these might be, for example, a whole preserve or part of a preserve or a wildlife crossing structure. You then create camera positions, and that is the exact spot on the ground where a camera was placed. You then deploy the cameras, And when you have deployed them and they've collected data, you would then upload the images, and there's a variety of methods that I just talked about for how you can do that. You would tag the images, and finally share the data. Somebody asked a question about sampling effort, and we do have whether or not we have tools for measuring sampling effort, and we do. We basically measure deployment time, and that allows you to indicate that a camera was out from one date to another date, operational sampling time. So the first step, creating an account. On the home page, you would see 2 different buttons you can click basically to create an account. Is it automatic account generation?
I mean, yeah, once they click on that button,
yeah. And you would just provide us some information to us about creating an account. And this would allow you to then log in. Once you've logged in, you have the ability to do things like create a project and change attributes of a project if you're the project manager. So you would, once you've logged in, you would see a button that says Create Project. And this basically is a description. It could be something, you might call it the I-90 project for those of you in Washington, or Highway 1 project if you're in California. Within that project, you would create monitoring locations. And these are large places that are part of your project area where you expect to set up 1 or more cameras to measure animal movement and occupancy, biodiversity, et cetera. So you would click on Create Location, and that would take you to a page where you could describe the location and how you're going to monitor it, and then put a point on a map. Finally, you're going to create camera positions, and these are within a location. So you can see the example on the left. The project is I-680 Wildlife Crossing. The location is a particular place along I-680, and this is an existing project, and you can see that there are 8 dots on the map, and those are all camera positions. You can create camera positions and add camera positions to a location. So you would go to the location and then add camera positions. And as a reminder, those are the exact spots on the ground where a camera is placed. You would describe it. You can also say things about what kind of camera you used, and so those attributes are associated with the actual monitoring position. And then you can add cameras. And what this means is you're going to use specific kinds of cameras. It could be cameras that we've already described. You'll see that in the top right. Or it could be different models of Moultrie, other models of Reconyx, Cutaback, whatever camera model you're using. And when you do that, you're going to use the Create Camera button. And so that's basically creating a description of a camera in the system. And so when you're managing in your project, you're indicating which cameras exactly are associated with your camera positions and with your locations, and that gives you an idea of how your sampling took place. And so it's a way to manage your camera systems. You can actually do this down to the individual unit level, so individual camera units if you want to use the system to manage your individual cameras in the field. You can also indicate your deployment time, your sampling time, and this is with the Create Deployment button. This indicates what the start and stop date were for cameras at particular monitoring positions, and that allows you to do things like manually or automatically calculate the rate of wildlife movement per number of sampling days. And so if you have cameras out there, you can capture camera sampling days. And then uploading images, and this is one of the most important tasks of managing the data in the system. And there's 3 primary ways I'm going to talk about. The first is you upload an individual image, and so we call this creating an observation. So basically you have a single image from a camera, you upload it to the system, and you attribute it with what was the animal species, what was the activity of the animal, et cetera. The bulk upload mechanism, we expect that Most people will use this method, and this entails, as I said earlier, capturing all of those images from a single camera. So this is a single camera position, capturing all those images in a folder or subdirectory, and zipping that up, uploading the zip file. It's associated with a single camera position, and the system will unzip that and create records for all of those images. And the cell communicating method I'm not going to talk about, but we do have a way for cell communicating cameras to automatically send images to the web system. So those who use cell cameras, there's a pathway to automatically upload the images, and then they can be tagged in the system. And we're using this in a couple of places in California and Colorado. Tagging images is just like it would be on any social media or other system. You would indicate for a single image or multiple images what's in the picture. And that could be an individual animal species. You could indicate things about demographics of the animals, numbers, genders, age classes, if you can tell, things like that. And the activity of the animal, especially if there's multiple photos showing you how they're behaving or acting. One way that things really speed up is if you bulk tag images, and the way that you would do this is to have multiple images. You can see this on the left. This is a crossing structure in Colorado. And it's basically, these are all different animals at different times, but they're all the same kind of animal doing the same thing. And that is a female mule deer that's crossing west to east. And it's a one animal, it's a female, it's a mule deer, it's an adult, and it's walking west to east. And so all of those attributes can be bulk associated with a set of pictures. So you would click on the box indicated just to the left of each image, click on all the ones that have the same thing going on in the picture, and then on the right you would tag the observations all at once. And so when you do this process, and we've measured this over hundreds of images, you can have time per image as low as 20 seconds per image. An important thing is once you've uploaded your data, you want to be able to track what's going on with the data. You can do that using the My Data tab, and you can also choose to download your data at different points to see what you've been able to measure. This will give you a CSV file export, which is basically something you can use in Excel, a type of spreadsheet. It's not the same as exporting all of your images. So this is exporting all of the data recorded associated with all of the images. We recommend, even though we do have all of your images on the web system and backed up, that you have a local copy of your images as well. So this is a way of managing all of your data, but we suggest that you also keep your data on your desktop as well. Okay, and then finally sharing data. And this is one of the most important steps in our mind of using a web system. So the web system we've set up is a very sophisticated relational database. It's queryable. It has lots of visual tools so you can manage your data. But for a lot of you, sharing the data is also important directly with the public or with partner organizations. Even in a private setting, you can just share it with partner organizations. But basically sharing your findings and quite often your success in improving animal movement or occupancy in some way. And this comes down to something that's maybe not scientific, but people love pictures of animals. And so this is one way that you can help your own project and monitoring wildlife in general is just sharing all of the images of animals. There are also automated summaries for each camera position, and in our next phase, and I'll talk about this soon, we're going to add more tools, but basically this just gives you an idea of the number of different species and number of individuals that have passed through over a given deployment time or sampling time, so you can measure success of your structure. I'm going to just pause for a second and try to answer some of the questions here. I'm going to start at the latest one and work back. are there ever issues with camera theft or vandalism when data such as camera positions are shared with the public? And so the camera positions are on a map. If your project is public-facing, we do have ways of setting up the project so that it is hard to tell exactly where cameras are, and you can also resort to the private setting if you want to. But for public-facing projects, we can make it hard to tell exactly where the point on the ground or the point on the map is, and that should help to some degree with security. Our Road Ecology Center camera projects are the ones that have been in the web system and the ones that aren't in the web system. They really have the same rate of theft, which is a gradual rate when people opportunistically find the cameras in the field. And we haven't noticed that projects that are on the web system have a higher rate of theft. So we don't think people are using the web system to find the cameras, but I guess it's theoretically possible. So some of our project findings, and these are things that are important, going forward or using the system, understanding how it could be used. Number one, we did come up with some optimal cell camera configurations, and this includes recommendations for the best ways to use AT&T data plan acquisition, which cameras might work best for different situations. For example, the Bushnell wireless cell cam, because it goes through their server, your ability to manage the pictures coming out of the server are constrained, whereas the Spartan Go Cam allows you to send the pictures wherever you want with a data plan, and so you have more flexibility with communicating your images. We developed a user-friendly web system. And this basically means that once you create an account and log in and you go through our help resources, you should be able to set up a project and manage your data fairly quickly. And we developed a cost-effective Wi-Fi camera configuration, and the cost-effective is relative to the commercial systems, and so it's still at the high end. This is a fairly expensive way to go compared to other ways of doing things, unless you factor in staff costs. And so the cell camera configuration and the Wi-Fi camera configuration both reduce field staff time, and the web system, and combined with the web system, reduce the time associated with managing images. And so overall, these systems do reduce staff time and costs. So that's one advantage of them. There is a learning curve associated with using these. For some people, these are entirely new systems. For most of us, using cell communication is not a new thing at all. And for most of us, using web systems is not a new thing at all. And so if we think of them that way, as basically learning how to use a new iPhone or a new website, then this is basically the same thing. There seems to be some variation in culture preparedness, how much people are able or willing to use systems based on some of their previous training and experience. We do have a fair amount of system complexity behind the user interface, and that basically means that some of the things like the ability to query data may not be obvious at first, so we recommend that you really investigate and ask questions about this to get more information. We have found that there's a little bit of contractor resistance, and I think people might be afraid that there could be some functional replacement of some of the things they do. But I think this is true for any technological advances, is basically contractors and others would have to adapt the kinds of services they provide in using a system like this. Some of our next steps, and these are areas that we think are important, and we welcome your input on this. The first is handling video, and I think there was a question about this earlier. We are going to add the ability to handle video into our system. We are making sure that the data is attributed in a way that it supports existing monitoring, sampling, and research formats for data, and so we want to support that. So we're trying to stay up to date with that. And then dealing with false positives, and this was another question about when you have all of those false positives that come from any camera trap system, how do you deal with those? And we are working on methods, automated image analysis methods for removing false positives, and related to that, automated methods for the true positives for identifying the species. And this would take place on the web system, so basically all uploaded images would be analyzed for species identification automatically. These are not currently part of the system. These are things that we are going to work on next. Another next step is that quite often if you have multiple cameras, or even a camera operating in burst mode or in video mode, you're dealing with events. And these are, we use this term when talking about, for example, an animal crossing through an area, using a particular area, then that would be an event, and you might have multiple observations related to that. And so we want to be able to handle these events within the database system without double counting, and it allows us to do things like measure the rates of crossing and rappel and other behavior associated with wildlife crossing structures. We're also supporting and want to continue and support more information mashups, so you would take traffic, noise, or other sound information, light information, other climatic or environmental information, and disturbance, and relate it to the activity that you're observing or recording with that image. And then finally, we want to have more automated analyses on the website. For example, an automated biodiversity index calculation for a location. Not finally, there's a few more next steps. We've tested the system in 6 states so far, and we would like to go for the majority of the country. So for those of you in states that we haven't worked with yet, then we would like to talk to you about that. Currently, we manage all of these web services through the Road Ecology Center server, but it is possible to develop a local instance of the website at a DOT or other government agency partner. And so we can also discuss that, how that would occur. And then finally, we need a pooled fund study to develop among multiple states to partner with state DOTs and making sure this is a system that really meets their needs. So one last polling question, and this is related to one of our next steps. Would you find some kind of automated image analysis tool such as species identification useful? And it's looking like most people would, so that's great. And so thank you for that. Now I'm going to take some questions. Feel free to also ask questions by email, fmschilling@ucdavis.edu. Our website is wildlifeobserver.net as a reminder. And so if you do have questions, please type them into the chat box. A note about questions and answers is that we are going to post all of these on the website along with the recordings of, and the slide presentations for the 2 webinars. So look for those on the website to come, especially for today. So if you ask questions or if you make comments, we're going to preserve those and share them with everybody. So this is really useful from a community building point of view. We can help share questions, find out what's important, and also share the resources, things that you know about. If I have talked about any studies or other things like that that you want more information on, please feel free to contact me and I'll send them to you. And right now, I'm going to go through and answer the questions that people have been asking or make some of the comments if they're relevant. So just keep typing them into the chat box and we'll get to them pretty quickly. All right, so question, will you eventually be doing some kind of metadata analysis on all of these web data? We hadn't planned that. We do keep track of how the system's being used, and we use that kind of analysis to help us think about what could make the system better. more useful to more people. So that's a form of that, but not a formal metadata analysis. So if that's something that you're interested in, the person who asked the question, please contact us. Another question, can you upload photos from folders on your hard drive that contain images from past monitoring? Yes. You would zip those up. They have to be associated with a position, so you'll have created a project, location, and position, and then you would upload that zipped folder full of images to the system. It would automatically extract and create records from all of those images. Another question, can you alter the effort to account for obscured days, for example, obscured by snow? Yes, you can do that. That comes down to your deployment time. And so you would modify your deployment time to reflect that your camera was not always sampling. Deployment and sampling are related, but not completely related. And so one way we can modify or use the system is to say your camera was out there for 30 days, but it was only sampling or active for 15 days. All right, another question. Can videos from cameras be automatically analyzed, not just photos? No, not currently. We are going to host videos and management of videos soon in our next steps. And then the analysis part of it, we are first going to do that with images and then later on with video. So the first step is just with still images. So the automatic analysis won't happen right away for videos. Excuse me. Somebody made a comment. I would emphasize that fewer visits to cameras would decrease the effects on wildlife behavior that wildlife avoiding people may have. And so that's a really good point. One of the benefits of these self-powered remote communicating cameras is that not only do you have less staff time associated with them, but you have less human scent associated with them. Another question, do you host any Canadian projects? We don't discriminate project hosting based on where people are developing their projects, so anywhere in the world. The system has been developed with Federal Highway Administration funding, and so it's primarily to support state DOTs, but we don't stop people from using it for other purposes. Another question, what is the cost to a state agency to utilize your program to download and store pictures? There's no cost. This is free, and will remain so. This is a federal government funded project to support the states in carrying out their activities associated with transportation primarily. Another question, wanted to ask about herptiles or low temperature non-warm-blooded species. A lot of crossings are being installed or reverted for amphibians and reptiles, and in some instances for arthropods and crustaceans. We've been using cameras for new western toad tunnels and red-legged frog crossings here in southwest British Columbia. Work well for motion sensitive, but what would be other options for these types of taxa? There's actually a paper in the Western section of the Wildlife Society meeting next week that talks about successfully using conventional cameras to monitor herptile movement. I think that it's worth thinking about other methods because of this temperature issues, and we have thought about a couple and would be happy to talk to you, the person who asked that question, so please email me and we can talk about that further. Another question, were trigger censored systems tested with all communication systems? Was one system better than another? I'm not entirely sure what that question means, so the person asking it, please retype it, but I'll give it a shot. We use the cell communicating and the Wi-Fi communicating systems, and we focused on making them effective individually, and we didn't compare those two with each other. And we didn't do side-by-sides basically with the different kinds of communicating systems. So I'm not sure we can answer that question about which is better than another in side-by-side tests, but in terms of individual system reliability and cost effectiveness, that was most of what we focused on, and that was part of the presentation today. Another question, can you customize the attribute fields for the images? No. but we can, and so it's possible to work with us to talk about what attribute fields would be useful to have in addition to the ones that we already have. So look at the ones that we have, and then let's talk about what might be good to add. There's a suggestion for an automated picture identification system, which we'll share as part of the follow-up. So look for that. Another point here, in very remote sites, could cameras be used for detecting wildlife for real-time mitigation response, for example, approach of sensitive animals requiring reduction in activities? Yes, and actually we had a cell communicating camera that was focused on a cattle crossing guard used to protect a fenced stretch of highway, and that can definitely be used. It would give you a slight lag time, whether you're using the satellite-based Wi-Fi or cell communication method, you would have a communication lag time, and so it's almost instantaneous but not as immediate as if you were to have a CCTV out there connected to some kind of communication line. Another question, how is an event detected? Event in quotes. That is the same animal in multiple images, which the questioner considers one event per detection. And basically, right now, the approach that we're working on is that you would be able to associate multiple images with a single event. We're working on that right now, actually. But currently what you would do is select an image that represents the event, for example, crossing through a structure, and upload that image. But in the future, we would like to collect all images associated with an event and store those so that they could be analyzed in a different way in the future. Will you be developing an API to allow data retrieval from other servers?
If there's a strong need for it, I think we would need to talk to the people who would want to use a service like that. Okay. So Dr. Wei-Chen, who is sitting right here, said yes, if there's a strong need for that, then we would look at doing that. That would definitely be in our next phase. And that could be, for example, mapped information that could be automatically brought into the map view. So the person who asked that question, please feel free to follow up with us about that. Can projects from other jurisdictions upload projects? Yes. No matter where you are, feel free to use our system to upload and manage projects. The important thing about that is if you are outside of North America, then your list of animals that might be observed isn't necessarily one we're going to have, and so you'd have to work with us on making sure that those animals were present in our animal list in the different drop-down options. Another question, has video live streaming been used with these systems to better understand how wildlife interact with a wildlife crossing as they approach and leave a crossing? There's definitely been recorded video used to understand that, and burst images, so multiple still images which are then put together into short videos, and that helps to understand wildlife behavior. The live streaming, there are live streaming webcams that have been set up that are associated with different kinds of wildlife. The most famous ones are usually birds, like nesting bald eagles, and so that helps us. So there's different methods that could be used, whether they're live or managed later. Another point, you mentioned at the beginning of your presentation that some cameras may be detracting or affecting species. Can you please expand on your findings and observations? The white light flash or low glow flash cameras are thought to have some inhibitory effect on use of areas by certain species, and that's why we have the progression towards the no glow cameras. A colleague at the Jepson Ridge Preserve at Stanford University, in his opinion, he's used many cameras, and he thinks the Buckeye series is the quietest and the least disturbing. But I think that we still have a little ways to go to understand how completely non-disturbing we've made these systems, including visually. They stand out in a lot of settings.
Another question, are any camera projects in the process of being developed on any major highways in California's Central Valley? We have had cameras in the Central Valley. One place was in the Cosumnes River Preserve looking at brush rabbit, riparian brush rabbit, which is endangered. Some of our camera systems are fairly low elevation on the edge of the valley in the lower foothills, so definitely have done some work in that area. Another question, we do not use the cameras for road monitoring. Ours are remote, but used for occupancy and diversity. Is there room in your system for including non-road data? Definitely. You'll notice that a lot of the attributes are set up so that you can talk about road association, but it's also possible, and some people have used the system for non-road projects. So the transportation part of it doesn't limit the use of the system, whether it's associated with transportation or not. Someone adds a comment, when setting up account and entering project information, it would be useful to add AADT. Absolutely. That's something that could be added currently as an additional resource, is saying what the traffic counts are with particular locations or positions. But another way to do this, which we've thought about, is having the mapped AADT, which is the average annual daily travel. So this is a traffic count. Having that in map form and having that part of the mapped information that's included in the website. So there's different ways we could do this, and it's definitely a great point. Somebody asked about camera theft, and it seems a general question, does anyone listening have any tips on reducing trail camera theft? If people want to answer that in the chat box, then this will all be included in the follow-up. So please include any tips you have on reducing camera theft, and we can share them with everybody. And the same person makes the point that we already have some tips on reducing camera theft. That's part of one of our help videos, so feel free to look at those as well. Another comment or question, we collect timed photos to quantify our camera effort, for example, days obscured, but only triggered photos are used for our occupancy calculations. This is done in an attempt to standardize zones of detection, making them represent the trigger range of the camera. Would the data management system be able to differentiate between timed versus triggered photos from a given camera? That's a different kind of data collection that we would have to talk about. So I'm assuming you mean time-lapse, or periodically the camera takes photos to quantify effort. And that seems like you could use that. Oh, so it is time-lapse, the person responded. So you could use that to indicate your sampling time in the same way, but those images, I'm not sure if we have a way to store those images themselves. So you could definitely use that information to say when the camera was sampling versus not sampling, but the images themselves, we'd have to talk about how to store those, and so they're part of your project management system. All right, so we are approaching the end of the questions that have been typed into the chat box. If you have more questions, please feel free to type them in, and I'll try to grab them right now in the last minute. One more question, couldn't you just use the timestamp off the images as a way to filter them? If that's associated with the timestamp, the time-lapse monitoring, then yes. And if your question is related to the timestamp on the images being used by the web system automatically uses the timestamp on the image as a way to create the record in the database. So that's already taking place automatically. Another question, would you use gloves when installing and maintaining cameras to reduce human scent? That's a really great idea. I use gloves. I think some people use gloves. I think that's a great way to go to mask scent on the camera. There's definitely some issues probably with the scent we leave behind without being able to help it as we just walk through a forested area or other area. All right, so I'm going to make that the last question. If you have any more questions, feel free to email me. at fmschilling@ucdavis.edu. Please feel free to check out our website, wildlifeobserver.net. And we have contact information there if you want to ask questions. And we look forward to all of you setting up accounts, logging in, and surfing around on the system. And I hope you all have a great rest of your day. Just as a last reminder, the PowerPoint, the recording, and the chat questions and answers will all be posted on the website. So thank you very much.